Dear students, in this video we will understand what is an onto function. Onto function, which is also known as surjective function. Function f from x to y, where x is the domain and y is the codomain, is said to be onto or surjective if every element of y is the image of some element of x under f. That means every element of y should be an image. No element of y should be left without mapping. That is, there exists an element x in x for every element y which belongs to the codomain set, such that there exists an x and f mapping happens and that is equal to y. So every element of y has a pre-image in x. That is what is the definition of onto function. Whenever a function is onto, range of the function is always is equal to codomain of the function. So if there exists at least one element of y which is not the image of any element of x, that is, any particular element of y is not mapped to any element of x, then range is not equal to codomain and the function is called into function. If a function is not onto, the function will be an into function. Dear students, watch the video completely. At the end of the video, I will pose a question for you. Comment and let me know your answer. Now, I have few arrow diagrams here. Let us check whether these functions are onto functions. Now, you check the codomain set. There are two elements E and F in the codomain set left without mapping. It has no pre-image in the domain set. So, this is not a onto function. Now, look at this. In this mapping also, there are two elements of the codomain set left without mapping. So, again, this is not an onto function. Here again, you check, there are three elements in the codomain set and all the three elements are mapped. All the three elements have the pre-image. So, range of this function is equal to codomain. So, is this an onto function? Yes, this is an onto function. Now, if you check the next one, all the elements of the codomain are mapped. They have pre-image in the domain set. Again, range of this function is equal to codomain. So, this is again an onto function. Now, let us take identity function as an example. The function is f of x is equal to x. This is how it is written. Identity function is from R to R, set of real numbers to set of real numbers. And the graph of the function is straight line passing through the origin, making an 45 degrees of angle with the x-axis. So, consider any point on this graph. It is always x comma x. So, every element of the codomain set, that is set of real numbers, has a pre-image in domain set. So, this is an onto function. But whereas you check the constant function is a line where this k is this part. Every element, you check the codomain set, every element, if the function is defined like this, if the function is from f from R to R, if it is from R to R, if the codomain is restricted to singleton set, then it is an onto function. But if it is not restricted and if the function is from R to R, then definitely it is not an onto function. This becomes an into function. Now let us understand what is a bijective function. A function f from x to y is said to be a bijective function if it is both 1, 1 and onto. If a function is both 1, 1 and onto, then it is a bijective function. Dear students, I have made a separate video on 1, 1 function. If you have not checked and you have any doubt in 1, 1 function, please watch the video completely, then come back and check this. Now look at this. We have clearly understood this is not an onto function, but it is 1, 1. It is 1, 1 but not onto. So it is not bijective. Again here, we have understood it is not onto function. So this is not bijective. Here if you check, this is onto but this is not bijective because two elements are mapped to same element A of the codomain set. If you check this one, this is both 1, 1 and onto. Since this is both 1, 1 and onto, this is a bijective function. So such functions are bijective functions. This is a question for you. Tell me, is this an onto function or not? Comment and let me know your answers.